So in this video, we're going to keep proving trig identities. So for example, prove that sine x over 1 plus cosine x plus 1 plus cosine x over sine x equals 2 cosecant of x. So one of the things to notice here is that I usually start with the messier side, which would be the left-hand side. So if we start with that, sine x over 1 plus cosine x plus 1 plus cosine x over sine x. The first thing that I'm going to want to do actually with this is make a common denominator. I have two fractions here and I want to put them together, and to do that I need a common denominator. So my common denominator is going to be 1 plus cosine x times the quantity sine x. Again, 1 plus cosine x times the quantity sine x. And so in the first fraction, I had the 1 plus cosine x already in the bottom, so I had to multiply the bottom by sine x, which means I have to multiply the top by sine x. So we'd have sine x times sine x. And in the second fraction, I had to multiply by 1 plus cosine x, so I'm going to have 1 plus cosine x times 1 plus cosine x. And then I'm just going to work out what that stuff is. So in the top here, we have sine squared x over 1 plus cosine x times sine x. And in the second fraction, we actually have to FOIL. So 1 times 1 is 1. 1 times cosine x is cosine x. 1 times cosine x is cosine x. And then cosine x times cosine x is cosine squared x, all over 1 plus cosine x times sine x. And so now I can put these together into one fraction. So I have 1 plus cosine x times sine x. And on the top, I have sine squared x plus, I have 1 plus I have 2 cosine x's plus cosine squared x. And then we can use the Pythagorean identity. I have a sine squared x and a cosine squared x, so together those make 1. So we end up with 1 plus 2 cosine x all over 1 plus cosine x times sine x. So we have 2 plus 2 cosine x over 1 plus cosine x sine x. And I can factor a 2 out of the top, so 2 times 1 plus cosine x over 1 plus cosine x times sine x. And my cosine x's would cancel 1 plus cosine x's would cancel each other out. So I'd be left with 2 over sine x, or 2 times 1 over sine x. And 1 over sine x is cosecant, so 2 times the cosecant of x. So this one requires a little bit of algebra to be able to put those two fractions together. So let's look at another one. So again, prove sine x over 1 minus cosine x equals cosecant x plus cotangent x. So again, I usually start with the left-hand side. The left-hand side is slightly more messy, I guess. So I've got sine x over 1 minus cosine x. But there's not a lot I can do with the left-hand side. So what I'm going to do is I'm actually going to kind of steal a trick from Math 126 from algebra, and we're going to multiply kind of like by the conjugate. So we're going to multiply, instead of a 1, we have a 1 minus cosine x on the bottom, so we're going to multiply top and bottom by 1 plus the cosine of x. And we're going to do that because maybe hopefully stuff will get a little better. So if I multiply things out here, I end up with sine x times 1 plus cosine x on the top. And on the bottom, I end up with 1 and then minus a cosine squared x. Those middle terms would go away. And then remember our Pythagorean identity says sine squared x plus cosine squared x equals 1. So if you move that cosine squared over, you would have that sine squared x is 1 minus the cosine squared x. And I happen to have a cosine squared x on the bottom, so that is going to turn into sine x times 1 plus cosine x all over sine squared x. Then it's actually not too bad. Algebra would tell us that the sine x and the sine squared would cancel each other out. So now I'm left with 1 plus cosine x over sine x. And since the bottom is a single term, I can split up the numerator. So 1 over sine x plus cosine x over sine x. And 1 over sine x is in fact cosecant of x, and cosine x over sine x is in fact cotangent of x. So a lot of these problems with fractions, you either have to do one of two things. You have to multiply by the conjugate, like we did here if you just have that one fraction, or if you have two fractions, like we did on this first one, then you need to put them together to make it into one common fraction.